Hello everyone, welcome to my presentation. I am Kazuhiro Umetani from Tohoku University, Japan. The topic of my presentation is the education method of a field of electric circuit technology called power electronics. So let me begin my presentation. Firstly, I'd like to introduce power electronics, as the topic of this session is somewhat different from this presentation. A simple definition of power electronics is that the power electronics is electric circuit study for power supply. So as you know, the electric power is utilized in various industries, from power generation to the consumer electronics. The electric power is generated in alternating current in power generator in many power plants, and also in a direct current in the photovoltaic power plant. And however, in various applications in the industry, the electric power is consumed in the alternating current or in the direct current in various voltages and various frequencies. The types of the electric power can be converted using the power conversion circuits, and the power electronics studies these power conversion circuits to improve the efficiency and reduce the size or the cost. Therefore, the power electronics is a technical field that is required for various industries. There are various technical fields in the electronics, but the important feature of the power electronics is that this study does not focus on the function. For example, in the design of the digital processors, for example, the major progress of the technology lies in more complexity in the circuit function. However, in the functions of the power conversion circuit, it's very, very simple. Here you can see the buck converter. This is a very simple, basic power conversion circuit. And the function of this buck converter is very simple, because the function is generation of low constant voltage source from high voltage power supply. That's all. So the function is very simple, but actually there are a lot of various products of buck converter supplied from many manufacturers. The difference of them lies not in the function, because the function is all the same, but lies in the quality, such as efficiency and the noise, power loss, and cost, and so on. So for these differences very important. So actually, the industry needs the skilled engineer that knows how to improve the output voltage stability and efficiency, but knows to reduce the noise, power loss, and the cost. So these are design optimization dependent on the requirement specifications of the actual product. And because of this wide variety of the required quality, this makes the power electronics education difficult. Like many other technical fields, the current style of power electronics education is comprised of the lecture course and also in hands-on courses mainly provided in universities. These education styles are mainly focused on to transfer the fixed knowledge for teaching the operation and function of the power conversion circuits. So these styles are very effective to teaching the operation and function of the circuits actually, but this may not be sufficient or may not so effective for teaching the case-by-case design optimization for better quality. So the purpose of this presentation is to propose a new power electronics education method and in this study, we developed and tested a new power electronics education method as introductory courses for newcomers to our laboratory. So this course is held in the Power Electronics Laboratory on Okayama University in Japan from 2015. The target of the education is 8 undergraduate students of the 4th grade, which are assigned to our laboratory. And this courses provides 2 periods of education. The first one is the basic course in which the student designed a simple basic power conversion circuit called the buck converter, the circuit I explained before. And the second one is advanced course in which the student designed a complicated circuit. But in the following slides, I will show you only the basic course, because actually in the advanced course, the basic style of education is almost the same. Well, so before presenting the detailed explanation of the course, I'd like to explain the basic concept of the education method. For educating the practical design optimization of the power conversion circuits, the competition-based learning can be very effective and promising approach. In this method, the students are divided in some groups, and the teacher gives the same requirement specifications, and each group designs its own products, the power conversion circuit. And then the competition is held and compare the performance of the product and finally determine the winner. This is a basic approach of the competition-based learning. This method is effective to encourage and motivate the students to focus on the practical aspect of the design, because they work on under the same specification but have to improve the quality. But the problem is that communication among the students are commonly limited after the competition. So therefore, the problem of the competition-based learning is few opportunity to share the design know-how among the students. So for avoiding the problem, we remembered how companies in the industry catches up the cutting-edge technologies. The company's business activity is very similar to the competition-based learning. The companies may make their products and compare the product performance in the market, and there will be a winner in the market. But the point is that after determining the winner in the market, the companies commonly analyzes the winning product, and feedback analysis results to improve their own product. So this is a cycle in a manufacturing process, and repeating this process is very effective for catching up the cutting-edge technologies. So this is a actual method of the industry. So our idea is to teach the student in this way. But of course, in industry, the analyze and feedback and make and repeating this process takes a lot of time. So we designed our education course so that know-how of the students can be shared frequently. Next, I want to explain the details of the introductory education courses. And we made 4 teams out of the 8 students and gave the same requirement specification as shown here. So this is a requirement specification of the buck converter they are required to make and design. And based on the specifications, each team is required to design and construct the buck converter and evaluate its performance. The winner is invited. The winner is also, of course, awarded to motivate the students. The winner is invited to attend the technical conference power electronics. And also it is very difficult for undergraduate students to make the product by themselves. So a mentor is assigned to each team to support the design process. A mentor is a master course students in our laboratory. And also, besides, the teams are free to consult with experts. So the PhD students in our laboratory. So this feature follows the common style of competition-based learning. But besides the competition, we also introduce the meeting to share the know-how of the students. So we held the meeting almost every week, and as shown here, and in the every week meetings, the students were required to report the design strategies to the teacher and share the knowledge of the design with other teams. The topic of the meetings is fixed in advance, all fixed in advance, as shown here. In the first week, the students should report the circuit parameter design, and in the second week, the students should report the detailed circuit, including the control circuit, and also they are required to report the selection of circuit components, and so on. The students are welcome to revise their design anytime after the meeting, as far as this schedule is kept in time. It is important to notice that redesigning is welcome at the cost of time for designing other part, because the meeting topic and schedule is already fixed. So the teams with the team that goes with appropriate design at the first time takes advantage in the time, and because they can focus, can assign much time for designing. So next, I'd like to show you the actual circuit design result of the students in the course held in 2017. We have 4 teams in this year, as it's normal in every year, as shown here. And these figures are circuit schematic of each teams. And it is difficult to see, of course, in the details of the design concept in the figure in this short presentation. But you can see that these 4 schematics shows great variety, at least in the complexity of the circuit, even under the same requirement specification and the same, and all the teams designing the same circuit, the buck converter. And next, the pattern layout of the printed circuit board is also different among 4 teams. The pattern of the circuit board has a parasitic inductance, and this inductance takes an essential role on the noise appearing in the DC input and output terminals. Therefore, appropriate patterns is practically essential for in professional design of the buck converter. And that is why, so they are thinking of how to design and the strategies for the pattern layers, and the students report why their design, why they design these patterns in the meeting in the 3rd week. And finally, these are photographs of the actual buck converters of these 4 teams, and that we can clearly see the same circuit under the same specification. This is a requirement, but resulted in the wide variety of buck converters in size, complexity, board layout, and so on. This variety of the design resulted in also great difference in the performance. For example, this is the efficiency evaluation results in the course held in 2017. The efficiency is the ratio of the output power to the input power. So the value should be close to 1. which indicates no power loss at power conversion. The worst design here, the team B, consumed 10% of the input energy as the power loss, although the best design team, the team A, consumed only less than 3% of the input energy. This difference is quite big because the efficiency difference of 1% is commonly indispensable in the actual market of the buck converters. Similarly, the input and output noise voltage showed great difference among the teams. This is a result of the this is a evaluation result of the noise voltage in the course held in 2018, and this one is a voltage noise appeared in the input power supply, and this is a noise voltage appeared in the output voltage. And as you can see, the amplitude of the worst design of both in the input voltage and output voltage exhibited more than 10 times a large noise voltage amplitude as the best design. So this is a quite big difference. In the last meeting of the course, the students presented the evaluation results and discussed how their design resulted in the difference in the performance. So throughout the course, the students learned the great difference appeared in the quality of the performance, even under the same circuit and designed under the same requirement specifications. So finally, I'd like to conclude my presentation. The motivation of this research is that the education of power electronics needs teaching how to improve the various aspects of the quality rather than just implement appropriate circuit function. Therefore, we proposed a new power electronics education method. This method is based on the competition-based learning, incorporating frequently sharing the know-how among the students. We developed and tested a new power electronics education method for introductory course for newcomers to the power electronics laboratory of Okayama University, Japan. The students experienced wide variety of the actual circuit design from the same circuit and the same specifications. They shared how this variety arose from the strategies to improve the quality. Consequently, we believe the proposed method is promising for power electronics education. So this is all my presentation. Thank you for your kind attention.